In this video, we will talk a little bit about a piecewise defined function and how to evaluate it. Now, if I'm given this function, f of x is equal to 4x plus 3 when x is less than 0, or 3x plus 5 when x is greater than or equal to 0, I can find the value of the function when x is -4, when x is 0, when x is 2. You can give any number in the domain, which the domain of this function is -infinity to infinity, but I can find the value of the function at any of those x's. So evaluate the piecewise function at the given values of the independent variable. Let's start with f of -4. When x is -4, -4 is less than 0, so I'm going to use the f of x is equal to 4x plus 3. That's the first step to these examples. I've got to determine which part of the function, which piece of the function I'm going to use. So when x is -4, we're using that f of x equals 4x plus 3. So I could fill in -4. So we have 4 times x plus 3, and in place of the x, I'll put the -4. Now, why did I use 4x plus 3 instead of the 3x plus 5? Because when x is -4, the piece that we use is the 4x plus 3. So that's -16 plus 3, or -13. So when x is -4, the value of the function is -13. Now, some students make a mistake of overdoing this, and what they do is put the x in for both pieces. X can only be, for this 4x plus 3, can only be less than 0. So all of the negative x's follow the 4x plus 3. Let's look at another value for x. So let's look at when x is 0. When x is 0, we're going to use the second piece. We're going to use f of x equals 3x plus 5. So f of 0, I'm going to replace the x with 0, and I get 5. When x is 0, we use the second piece, so that value is 5. And let's try one more, f of 2. When x equals 2, we're using the second piece, again, the 3x plus 5. So if I replace the x with 2, I get that f of 2 is 6 plus 5, or 11. Now, one other thing I could do here is I could show the graph. Sometimes, now this question didn't ask us to do this, but you should be able to also graph the function. So let's graph the part of the function where x is greater than or equal to 0. We'd go up 5, 1, 2, 3, 4, 5, and then from there we could go down 3 and left 1, down 3 and left 1, down 3 and left 1, and so on. So up until the point where x equals 0, we follow this blue line. But then when x is greater than, Now, this question didn't ask us to graph, but I can graph the function as well. And here's how we would graph. Every part of the axis where x is less than 0, I've highlighted that pink, is going to follow the 4x plus 3. So I could graph y equals 4x plus 3. Let's start here at the 3. Oh, but you know what? I didn't want to include that 3. I wanted to just go up to x equals 0, but not touch that. And we have the slope of 4 over 1, 1, 2, 3, so negative 4 over negative 1. So it would follow this line. Here's the line, y equals 4x plus 3. And when x is less than 0, we follow that line. But when x is greater or equal to 0, we're going to follow the line 1, 2, 3, 4, 5. Y equals 3x plus 5. Now, unfortunately, my graph is going to go off the coordinate here because we're going to rise again, but we're going to go up 3 and right 1. So let's just 1, 2, 3, and 1. So it'd look like this line here. And then here's the line, y equals 3x plus 5. But for all the values of x that are in this blue region, so let me include this because it goes infinitely. So we could imagine that graph going up infinitely. I just should have used a coordinate plane that was a little bit higher, or I should have used these values. I should have scaled it down a little bit, but you could still see the graph. Let's compare our values with this. When x was 2, notice that we fell into the 3x plus 5 and we got 11. When x was 0, we were right here on the value, right here on the axis, so y equaled 5. And then when x was a negative, we were in the pink, so we followed this pink function down and we got a negative 13. This question didn't ask us to graph, but sometimes you want to also be able to graph a piecewise function. And I hope that gives you a good base to jump off from and to practice graphing other piecewise functions and evaluating them.